Hello everyone, in this video we are going to solve an important previous year JEE Mains question based on the binomial theorem. We will carefully understand the concept involved in the problem and learn an easy approach to solve this type of question step by step. This question was asked in January 2026 session, so it is very useful for all the JEE aspirant. Let's get started. Now let us carefully observe the questions. In the questions asked find the coefficient of x power 48 in this expression. Expression is 1 plus x plus 2 1 plus x whole square plus 3 1 plus x power cube up to 100 into 1 plus x to the power 100. So if we find the coefficient of x power 48 in this expression, so it is very difficult to find each of the expression to find the coefficient of x power 48. So if we find the coefficient of x power 48 in this expression, so we start with like that 48 1 plus x power 48 up to 100 1 plus x power 100. So start with here to end this. So it is very difficult to find the coefficient of x power 48 each of the terms. So now we approach the another method to find the coefficient of x power 48. Let us clearly write this total expression, and it is denoted by s is equal to 1 plus x plus 2 times 1 plus x whole square 3 times 1 plus x whole cube up to 100 1 plus x power 100. Now we multiply the above expression by 1 plus x. So it is changed by very nicely. 1 plus x into s. So it is multiplied by 1 plus x. Then this term is reduced to 1 plus x whole square. Then second term is 2 times 1 plus x whole cube plus 3 times 1 plus x 4, and this term, before this term it is 99 1 plus x power 99. So 99 1 plus x to the power 100 plus 100 1 plus x power 101. Now we numbering these two expression 1 and 2. Now we subtract these two expression 1 minus 2 we have. Then we get s minus 1 plus x s is equal to, if we subtract this from this, so this term is same 1 plus x. We subtract this from this, so 2 minus 1 is 1. This is 1 plus x whole square. 3 minus 2 is 1. Then third term is 1 plus x cube up to this minus this is 1 plus x to the power 100, and last term is minus 100 1 plus x power 101. So the left hand side is s minus 1 plus x into s, so it is x into s, and right hand side we see 1 plus x plus 1 plus x whole square up to 1 plus x to the power 100. If we carefully see this expression, so we get an GP series. The first term is 1 plus x, second term 1 plus x, so we multiply by 1 plus x. So 1 plus x, which is the first term, second term 1 plus x, the common ratio is 1 plus x up to 1 plus x power 100, and last term is 100 1 plus x power 101. Now we apply the GP series sum property. Suppose the GP series is ar square up to ar power n minus 1. The sum property is equal to ar power n minus 1 r minus 1 if r is strictly greater than 1. If is strictly less than 1, then the sum is 1 minus r power n 1 minus r if r is less than 1. So we apply this sum property here. Our expression is x into s is equal to, first term is 1 plus x and common ratio is 1 plus x, so 1 plus x. And how many terms are here? 1 2 up to 100. So the terms are, the number of terms in GP series 100 minus 1 plus 1, so it is 100. So nth value is 100, that is actually n. So here is 100 minus 1 over 1 plus x minus 1, and the last term is same, last term is minus 100 1 plus x power 101. Now we simplify this expression. Is 1 plus x over 1 plus x power 100 minus 1 minus 1 plus 1 cancel. Now it is rest is x and minus 100 1 plus x power 101. Therefore s is equal to 1 plus x power 101 minus 1 plus x over minus x square plus 1 plus x power 101 over x. So we divide minus x in right hand side. Therefore s is equal to 1 plus x 101 over minus x square plus 1 plus x over x square plus 100 1 plus x power 101 over x. Now we find the coefficient of x power 48 here and here. This is 1 plus x over x square. So x power 40 is not is here. Now we expand this term in binomial expression and this term and this term. So s is equal to minus 1 plus x power 101 over x square plus 100 1 plus x power 101 over x plus 1 plus x over x square. Now we expand 1 plus x power n, it is general term is 1 plus nc1. We write as a note x nc2 x square up to nc n x power n. Now if we expand this 1 plus x power 101, so 1 plus 101 c1 x and so on 101. We find the coefficient of x power 48 and here is divided by x square, so we need to find the coefficient of x power 50. So x power 50 is 101 c50 x power 50 and last term is x power 101, and we find the coefficient of x power 48 from here, so it is divided by x, so we need to find the coefficient of x power 49 from here. So we expand this term in binomial expansion 101, same expansion, same things. We need to find the coefficient of x power 49 is 101 c49 x power 49 and rest of are same. So we take the coefficient of x power 50 from here and x power 49 from here and put it here. Therefore the coefficient of x power 48 for s is equal to minus 101C 50 plus 100 101C 49. This is the coefficients of x power 48 of the given problems. Now we clearly write it 100 101 C 49 minus 101 C 50. So if we see the option of this question, it will be in the option 3. So option 3 is the correct answer. Now overall the question we are doing, we take total expression, it is denoted by S. The expression is 1 plus x plus 2 times 1 plus x whole square up to 100 1 plus x power 100, and we multiply 1 plus x over S, it will get 1 plus x power 2 times 1 plus x power cube up to 100 1 plus x power 101. Then we subtract this term that is denoted by 1 and denoted by 2. We subtract 1 minus 2 and we will get an GP series, and find using the GP series sum property we will find the sum of this S, and this is the nice form we get, and we find the coefficient of x power 48. That is very easy to find. In this process to finding the individual of this coefficient of the expressions. So answer we, the coefficient of x power 48 of S is 100 101 C 49 minus 101 C 50. This is the correct and final answer.